All right, next we're going to hone in on the importance of mass extinction events. I have to tell you that mass extinctions, much like predator prey dynamics, can be pretty gruesome. But life has always risen from the ashes. And extinction events are followed by incredible adaptive radiations of new species, which otherwise would never have existed if not for the carnage of mass extinctions. In our evolution modules, we spent a great deal of time on microevolution, which you recall is simply changes in allele frequencies from one generation to the next or across space. Today, we'll be thinking about the other end of the spectrum, macroevolution, sweeping changes we observe in the fossil record above the species level, such as the colonization of land by tetrapods, the evolution of flight in the theropods that we now call birds, or the impacts of mass extinctions. We recognize that the fossil record is bound within the geologic record, which is systematically divided by geologists into units like eons, eras, and epochs. And boundaries between these defined geologic periods are often marked by extinction events. In this learning activity, we have thus far explored major evolutionary events with respect to animals in the Paleozoic, Mesozoic, and Cenozoic eras. We paid special attention to the Cambrian explosion right here, 535 million years ago. Here, we're going to take a closer look at two of the most famous or infamous extinction events. The end Permian, 252 million years ago, also known as the Great Dying, and one you may be familiar with, the end Cretaceous, 66 million years ago. So, quick note, both eras as well as some of the periods are fair game on your next assessment. So make sure you've at least got the order relatively correct of the eras and periods that we discuss. Huge idea. Extinction is not the exception on planet Earth. Extinction is the rule. All species, including us, will eventually go extinct. In fact, estimates suggest that 99.99% of all the species that have ever lived throughout the history of planet Earth are now extinct. A mass extinction event is defined as an extinction event within which more than half, more than 50% of marine species on planet Earth go extinct. So mass extinction events are caused by extraordinarily and thankfully rare events like supervolcanoes or massive asteroid collisions or runaway climate change. So it depends upon your criteria for how you define a mass extinction event, but most paleontologists conventionally define five, the big five, including the end Ordovician here, which killed many of the lineages of the trilobites, the end Permian, which, like I mentioned, is also known as the Great Dying. This is the largest and most devastating extinction event in our planet's history. It killed more than 96% of marine species and over 70% of terrestrial life during a time of massive Siberian volcanic activity. We also have the end Triassic, which is going to allow the dinosaurs to take over the planet, and the end Cretaceous, which is going to allow for the radiation of mammals during the Cenozoic. Some, including myself, would argue that we are now in the midst of the sixth mass extinction event. But this one is not caused by supervolcanoes or asteroids. This one is caused by a cosmopolitan African ape that will soon reach 9 billion people and is transforming the planet as no species has done before. We'll come back to the idea of the sixth mass extinction when we discuss conservation biology later in the semester. So, we cannot talk about the evolutionary history of life on our planet and not give props to the dinosaurs. I'm just a big kid at heart and I still love my dinosaurs. So, this incredibly diverse group of reptiles evolved some 230 million years ago. And following the Triassic Jurassic extinction event, they go on to become the dominant terrestrial vertebrates on the planet. So, when most of us envision dinosaurs, we think of the terrible lizard king, Tyrannosaurus rex, which, I might add, a recent publication concluded likely had feathers on its upper torso for thermoregulation. And it's no wonder that Tyrannosaurus captures our imagination. So this apex predator grew to 40 feet in length, and it weighed some 18,500 pounds, allowing it to do battle with formidable prey like the armored and club-wielding Ankylosaurus. But we have to remember that dinosaurs ruled the planet for 165 million years. The mammals have ruled for 66. So, given that amount of time, they evolved into every conceivable ecological niche. Dinosaurs were massive, but dinosaurs were also small. They were carnivores, but also herbivores and insectivores and piscivores. They were quadrupeds on four legs, bipeds. There were also lineages of massive aquatic reptiles that returned to the ocean, the plesiosaurs and the mosasaurs. And of course, there were the flying pterosaurs. What most people don't know about the dinosaurs is that they were tetrachromatic, meaning they saw four primary colors like modern reptiles today. And undoubtedly, they came in an array of striking colors that evolved in response to sexual selection, just like we see in modern day birds. Remember those birds of paradise? I'm sure there were comparable dinosaur displays. And let us not forget about the hadrosaurs, or the duck-billed dinosaurs, some of which had these elaborate crests on their heads that contained long and resonant extensions of their breathing tracts. So these tubes could easily produce low-frequency sounds, bellows, probably serving as alarm calls for their herd mates to alert them about incoming predators. Maiasaura, a hadrosaur, which is deemed the good mother lizard, tended her nest and fed her hatchlings. Parental care, which is almost non-existent in the reptiles today, but we do see it in one reptilian lineage. It happens to be one of the few large-bodied reptilian lineages to make it through the end Cretaceous extinction event 66 million years ago. I'll give you another hint. They have four-chambered hearts, whereas most reptiles extant today just have three. Who is it? Who takes care of their young? The crocodilians, the alligators, the crocodiles, and the caimans. They're one of the larger reptiles that make it through the end Cretaceous with their four-chambered hearts still exhibiting parental care like Maiasaura. So dinosaurs and aquatic reptiles and flying reptiles filled every conceivable ecological niche on our planet for 165 million years until that one fateful day 66 million years ago in which the world was changed forever. An asteroid estimated to be 6 to 9 miles in diameter. That's the size of Manhattan. Traveling at an estimated 44,712 miles per hour. Smashes into our planet with an energy equivalent of 100 trillion tons of TNT. That's 21 billion Hiroshima atomic bombs. Unlike anything the world had seen for billions of years. It generated a cloud of superheated ash and steam, killing everything for hundreds, if not thousands of miles. It triggered perhaps the most massive earthquakes the world had ever seen and tsunamis around the world. Further, trillions of tons of material were ejected into the atmosphere, initially raising global temperatures and causing raging forest fires all around the globe. The water, the air, the soil, they were all poisoned with cyanide and heavy metals, nickel and lead from the asteroid itself. The sulfur released into the atmosphere caused acid rain and then a global cooling known as a nuclear winter, blocking out the sun, possibly lasting for decades. The loss of photosynthesis reverberated throughout the food web, and all of the large-bodied animals greater than 55 pounds, with the exception of the crocodilians and the sea turtles, who do manage to make it through, all the other big reptiles blink out. It was literally hell on Earth. The impact site, known as Chicxulub Crater, is hidden beneath the Yucatan Peninsula and the Gulf of Mexico. The buried crater is over 93 miles in diameter and is 12 miles deep, well into the continental crust. Need more evidence than a giant crater? The end Cretaceous is marked by a thin layer of iridium, which has been detected at hundreds of sites all around the world. Iridium is a very rare element in the Earth's crust. However, it's abundant in meteorites. Directly above the Cretaceous fossils all around the world, we find this dark layer containing unusually high concentrations of iridium, about 100 times greater than what is normal in the rest of the strata. Why? Because that asteroid filled with iridium vaporizes on impact, and that cosmic iridium dust then rains down all over the planet, creating a thin layer of dust that is still detectable in the sedimentary rock all around the world and marks the end of the Cretaceous period and the close of the age of dinosaurs.